Good morning, students. Am I audible? Please do inform everyone to join. Okay. So this is a class of professional elective one, sixth semester. That is railway engineering. So we have come to the end of fourth module. Fine. So in the fourth module, mainly we have discussed about point and crossing, or you can say the turnout. The basic mechanism uh, based on which a particular rail can change its track. We have already understand, right? Different component of point and crossing. We have also discussed about that, like stock rail, closer rail, point rail, what is tracer bar, what is switch motor, switch bar, isn't it? Then frock, which is a main part of the crossing, nose angle, wing rail, guard rail, nose angle. All these things are discussed in up to last class, right? So I hope this it is clear to you. So today we'll discuss about something which is related to your point and crossing, or you can say turnout. It's also known as basically a track junction. Okay, so basically it's a junction. Okay, where junction is a particular point, a particular section of a railway track, where a facility is provided for a particular train to cross over a track. Okay, so it's a railway junction. So regarding railway junction also you have heard this term. Okay, so basically we are going to discuss about different types of railway junction that can be adopted or can be used in different uh, railway junction basically. Okay, so maybe you have seen different larger railway junction nearby a different area by traveling through a train. That particular junction is basically is giving a it's because of the giving the way or different way to the particular train, so that a particular train can move from one track to another track. Okay. Okay, clear. So let me allow to share my screen first. Okay, my screen is visible, right? Please do respond.
Yes, sir.
Okay. So so we are going to discuss about track junction. Okay. So basically, track junction is what? It's a combination of numbers of point and crossing. Okay. So basically, if you are considering one section, one railway section where particular we're talking about point and crossing, right? So a particular combination of point and crossing is basically known as turnout. Okay. But as a whole, if a particular location where numbers of point and crossings are there, so it will call a track junction. Fine. So basically, what is a track junction? It is formed by the combination of point and crossing. Basically, their main objective is to transfer rail vehicles, or you can say the locomotive or the rolling stock, from one track to another, or to enable them to cross from one track to another. Okay. So depending upon that requirement of traffic, there can be several types of type of track junction with simple track layout. Okay. So depending on the availability of space, depending upon the traffic volume. Okay. The based on these two factors, different types of track junction can be classified. Okay. So let's discuss about the different types of track junction. Like the first one is your basic one, that is your turnout of similar flexure. That similar means what? In the same direction, basically. Okay. So so it is this type, basically the turnout of similar flexure. A turnout of similar flexure continues to run in the same direction as the main curve or main line curve even after branching off from it. That means you are providing turnout of similar flexure in a particular location where we need different track but in the same direction. Okay. Here you can see this is the basic diagram, line diagram for a layout diagram of a turnout of similar flexure. Here you can see this is a main line. I will show you with some marker. Let's see. Yeah. So basically, is your main line, and this is the turnout. Basically, okay. This is the turnout. Okay. I think it is written also here. Okay. I will show you. I think now you can see it will be visible larger. Okay. So this is your main line, and this is your turnout. But if you look closely, they are moving or directing in the same way, or you can say it's in the same direction. So a turnout or similar flexure continues to run in the same direction as the main line curve. Which is this one, the main line curve, even after branching of it. Okay, so from this point, this is a point section. This is your crossing. Okay, but even after the crossing, also the direction will not change. Direction will be same, but only difference is it changed the track. The degree of the turnout curve will be higher than that of main line curve. That means the degree of curve. I think you know about the degree of curve, right? Degree of curve means I'm just showing you roughly. This is the degree. Okay. If I consider this turnout branch curve, this is the degree. Okay. And for the main curve, I'll show you from here. This is the degree of the main curve. Okay. Like that. So yeah. So the degree of the turnout curve, that is this curve, will be higher than that of main curve. Okay. The degree and the radius of the turnout curve can given by this formula. That means you can, if you know the degree of the curve related to your main line, then you can also define or determine the degree of curve and radius of the curve related to your turnout. Okay, you can determine. Okay, by using these two simple formula. If you know degree, you can use degree to find out the degree of the um, turnout curve, T for turnout basically, and radius of turnout. Okay. Now here you can see in this particular formula, suppose you have used only degree. Okay. So here your ds, that is your ds represents what? Your degree of the outer rail of the turnout curve from the straight track. That means this is a straight track. Okay. And this is the outer of the here you can see this is a straight outer curve basically, and ds represents the degree of this curve. Okay. And dm is the degree of the rail of the main track on which crossing lies. That means this is the main track, right? I'm talking about this. Like, okay, wait, yeah. So dm is what? Dm is your degree of the rail of the main track on which the crossing lies. That means this is okay, fine. And dt is what? Dt is the degree of the rail. Dt is what? T for turnout basically. So dt is the degree of the rail of the turnout curve on which the crossing lies. Okay. So basically about this rail, I'm talking about this rail. Okay. Okay, somebody is waiting. So for now, just try to understand the basic line diagram or the profile layout of different types of uh, basically different type of track junction. Okay, these things are enough for now. Okay, so what is the basic information lie behind this turnout of similar features means what? The branch line have the same direction, similar to the main line basically. This is things are very important now. Okay. So anyway, so let's go to the different shape. The which one? Number 2, turnout of contrary flexure. Contrary flexure means in the opposite direction. Okay. So it's just a kind of opposite of this turnout of similar flexure. It is just the opposite of number 2, that is turnout of contrary flexure. So a turnout of contrary flexure takes off towards the direction opposite to that the main line. So, okay, so it's just the opposite. So since the main line is in this direction, so here you can see it is going in a different opposite direction. Fine. So you can see, and to find out the degree of the turnout curve or radius of the turnout curve, you can use the same formula for which is used for turnout of similar flexure, but just a little modification like this. You can see only in place of plus you have to put minus. Okay, other things are similar. To find out degree of the turnout curve or radius of the turnout curve, you just try, if possible, try to remember the formula for one. Another one it's just the opposite. Okay, so you only have to remember positive sign will come with this similar flexure, negative sign will come with the turnout or turnout of contrary flexure. Okay. Okay, so next discuss about the third one. This is our symmetrical split. So from the name itself, it is very easy to understand. Symmetrical. Okay, so I'll show you from diagram. See. Okay, so from this diagram also it is understandable. That is, suppose this is your facing direction. That means a train is moving from left to right in this direction, and you can see there is no main line going straight. The both uh, tracks are diverging from this point and they are symmetrical to this center line. This, can you see this dashed line? This dashed line lie in the center line of the straight curve. Okay, and from the straight curve, the both divergent track are going in the opposite direction, but in the similar manner. That means they are symmetrical about this axis center line. Okay, so when a straight track split up in two different directions with equal radius. So mind it, why it's called symmetrical? Because both turnout track have equal radius. Okay, and the layout is known as the symmetrical split. In other words, a symmetrical split is a contrary flexure. That means the symmetrical split, it's kind of a modification of contrary flexure. Even you can see turnout of contrary flexure in case of the number 2. You can see both are moving in opposite direction. So it's look like similar. But what is the difference between these two? That is point number 2 and point number 3. What is the difference? This is the difference, equal radius. In case of symmetrical split, the radius of the turnout curve are similar. That's why it's called symmetrical. Okay, but it is not the case in contrary flexure. It can be in different radius or different degree of curve. Okay, it's but they should be in opposite direction. Okay, yeah. So in other words, a symmetrical split is an contrary flexure in which the radius of two curves are the same. Other silent features of symmetrical splits are the following. Like the layout consists of pair of points, acute angle, one acute angle, acute angles, and obtuse angle. About this, yeah, I think it is familiar to you. I think it's from coming from mathematics. Acute angle means the angle ranges between 0 to 90. Obtuse angle means 90 to more than 90, basically. Okay. Okay. Is there something? Wait. Yeah. Okay, so a layout consists of a pair of points. That means different pair of points means what? You can see different points will be there. Okay, one set of points for this where I'm. Yeah, yeah, it's here. One set of point for this track, one set of point for this track, right? That's why we need a pair of points. Then acute angle, then four curves lead rail. This they are lead rail, right? So four curved lead rails and two check rails. So here also we need a check rails. Okay, this one you can see basically. You can see the check rails. They are the check rails. Two check rails. Okay. So layout is symmetrical about the center line. So here you can see this is the center line, and both tracks are symmetrical about this line. Okay, this means the radius of the main track as well as the branching track are equal. That means if you consider this one the main track, if you consider this one is a branch rail or branch track, so the radius of both are similar. The layout provides the facilities for diverting vehicles both direction, left and right. That means in both direction, from left to right or left to right or right to left. From both direction, diversion can be possible. Next, it is suitable for location with space constraint. That means if in some areas uh, there are no space available for different uh, diverging track, so you can go for combining both, and you can make a symmetrical split. It will reduce the space. Okay, so if space availability is less, you can go for symmetrical split. Okay. Okay. So this. Wait. Okay. Fine. So it is suitable for location where space constraint, as it occupies comparatively much less space than a turnout from straight curve. That means turnout from space. Uh, uh, okay, that means we are talking about this. Suppose from straight curve you are moving a turnout. Okay, so that comparatively the space requirement for symmetrical split is less. Okay, so after that, let's come to that fourth one, that is three throw switch. So what does this mean basically? So let's see this diagram. Okay, three throw switch, contrary flexure. Basically, these are also contrary flexure. So that means you are diverting track in both direction from the straight. Okay, it may be in the opposite direction or it may be in the same direction. They are called three throw switch. That means from one section point we have a three track option in different direction, either in the same direction or in opposite direction. They are called three throw switch. Okay, so basically in a three throw arrangement, two turnout takes off from the same point of a main line trick. Okay, A three-throw switch can have a contrary flexure or similar flexure. Contrary flexure means what? They are going in opposite direction. Similar flexure means they are going in the same direction. Okay, or you can say contrary flexure or similar flexure. Contrary flexure, you can see they are moving in the opposite direction. Similar flexure, they are moving in the same direction. So a particular three-throw switch can have a facility for contrary flexure, can have a facility for similar flexure. Okay, even from the diagram also it can be easily understandable. Okay, this is your contrary flexure, this is your similar flexure. Okay, the three-throw switch are used in the congested goods yard. That means where space, even again when space are very less, and at entry point of locomotive yard where there is a much limitation of space. If there is a limitation of space, that again you can go for this type of three-throw switch. For if space is less, and more about that, if your volume of, or you can say that traffic volume is large. Okay, that means you can go. You have to go for more than single line, branch line. You have to go for double line, double branch line. Then you have to go for three-throw switch, either in a similar flexure, either in a contrary flexure. Okay. So let's come to double turnout. So a double turnout or tandem is an improvement over a three-throw switch. So double turnout, basically it's a modification version of three-throw switch. Okay. In a double turnout, turnouts are staggered, and staggered means randomly, basically random or in a series, and take off from the main line at two different places. That means point will be placed at different location. Here you can see at the same location, basically from this point the all our branches are coming out. Okay, but in this case, in the double turnout, we have a two different location for branches. That means they can take off from the main line at two different places. Okay, I'll show you a diagram. Here you can see this is one point, this is your second point, or you can say this is one first point, this is your second point. Okay, if you are closing, if you go for activating this point, it is AB. That means what will happen? It will either it will go straight, or either it will go. Let me take the pen. Okay, okay. So if you activate this AB point, so the train have an option of going in this direction, either yeah, let me see clearly. Yeah, in this direction, in this direction. Okay, and if you are activating this A dash B dash point, that means a train may have an option of going in this direction or in this direction. Okay, so this is called kind of a modification of your three-throw switch. So it's called double turnout. Okay, so in this double turnout, the branches can take off from the main line at two different places. Double turnout can be of similar flexure when two turnout take off on the same side of the track of the, and counterflexure when the two turnout takes off in the two different direction. So you can see this, since these branch line are in the same direction, that's why it's called similar flexure. And now from this you can see two different location where the points are fitted. This first point AB and CD, different second point. Okay, so uh, this is basically a counterflexure because the branches are in an opposite direction of the straight main line, basically. Okay, so in a mainly, what is the main significance of double turnout? They have a double point. Okay, you can say double point where two different location, from two different location there is a possibility of a train or facility provided to the train to go in a different direction, either in the same, in a one side or opposite direction. Okay, next, diamond crossing. Basically diamond crossing is like look like a diamond, that's why it's called diamond crossing. And diamond crossing is provided when two tracks of either of same gauge or different gauge cross each other. It consists of two acute angle and a two obtuse angle basically. Okay, this is here you can say obtuse angle here. This is the acute angle. Okay, A and C here. This angle and this angle. You can see this B and D angle. Okay, this is A and C here less than 90 degree. Here B and D is the more than 90 degree angle. Okay, so here in the diamond crossing basically is provided to cross over one track to another track. That particular track either having a similar gauge or different gauge. Similar gauge means this particular, suppose this is your main track, it may be your broad gauge. Then this is your suppose another track, it may be your branch, standard gauge or meter gauge, narrow gauge, anything or similar. Okay, but in diamond crossing, one track cannot cross each other. That means one train moving in this track, it cannot move in this direction. It have to move. It's not possible. It's have to move in this direction. Okay, or a particular train moving in this direction is have to move in this direction. It cannot move in this direction. Okay, so even here also written here in a double crossing, the track cross each other, but the train from either track cannot change track. There is no facilities provided here. Okay, now we can go for improving this diamond crossing by providing single slip or double slip. Okay, now let's discuss about what is single slip and double slip. In a diamond crossing, the track crosses each other, but the train from either track cannot change track. Okay. Now slips are provided, especially apparatus is provided. Slips are provided to allow vehicles to change track basically. Okay. The slip arrangement can be either single slip and double slip. In the single slip, there are two sets of join basically. The vehicle from one direction can change track. Okay. So I will just show you in a diagram itself. From the diagram, it will be understandable what is single slip and double slip basically. Now here you can see in this diagram. This diagram is basically all about your single slip. Okay. This diagram is basically about your double slip. Now let's discuss why it's called double and single basically. Now why it's called single slip diamond crossing, because here you can see a train moving from in this direction can go in this direction. Okay, a train moving from in this direction go in the straight direction. It is possible. It's obvious. Also, in case of if it is single slip, a train coming from this A, okay, from this can also have a facility to go in this direction. Okay, so that means a particular train moving along this AB track have a facility to move in a straight direction or in this diversion. Okay, but it is not the case for this track, because here you can see if a train moving along CD, it have a if it can only move along this straight direction. Okay, that is not a possibility. That's why it's called single tip, and it is possible because of this. What? Because of this. Here written, slips are provided to allow vehicle to change the track. A slip arrangement can be either single slip or double slip. In single slip, there are two sets of joints. That means these joints, A1, D1, A2, D2. They are basically the joints which are provided to join this line. Okay, fine. But that's why it's called single slip. Okay, in case of double slip, what will happen? So there is possibility for a train to move in both direction. That means a particular train moving along AB can move or can change a track along CD. Also, a train moving along CD also have that facility to move or change track along AB. Okay, so it's called double slip. Okay, the directions are also provided here. You can see AB, BA movement is possible. CD, DC movement is possible. It's called diamond crossing. Okay, AD, that means A to D is possible, D to A is possible, C to B is possible, B to C is possible. Okay, so it's called double slip. But here you can see A to B is possible, B to A is possible, even C to D and D to C is possible. It's a double crossing. But A to D is possible, D to A is possible. Only one cross direction is possible, but from B to C is not connected. Okay, because there is no double slip. Only one pair of joints are provided to connect A and D. Okay, fine. So yeah, this is about your diamond slip. Now this your scissor crossover. That means it's look like a scissor. Okay, that's why it's called scissor crossover. So this scissor crossover enables transferring a vehicle from one track to another track and vice versa. Okay, it is provided where a lack of space does not permit the provision of two separate crossover. That is where there is a traffic volume is large and space is less. In that particular area, you can go for scissor crossover. Okay, that means a particular train which are moving along this direction can go in straight direction and can go in this direction. The train moving along this direction can go in straight direction and also can go in this direction. Okay, and vice versa. In the opposite from opposite direction also is possible. That means both are connected. Okay, all these two tracks, straight tracks are connected by this branch line. Fine, fine. So this is all about your serial crossover. Okay. Now the last one, your gundulated track. Gundulated track basically it is a temporary diversion. It is not a permanent one. Basically, this track was provided in the railway section where a maintenance work is going on in the main track. So, in case of emergency, when to divert the rail from the main track, then you can go for connecting this gantleted track basically. So I'll show you this diagram. You can see. So you can see this is our main track basically. This is your main track. Okay. There another parallel track is going on. Okay. Now suppose there is a maintenance work is going on, which is my emergency work is going on. Okay. Now you are not you cannot register movement of the track. What you can do? You can divert. You can divert the railway direction by providing uh, this special type of track. Okay, and this track is basically facilitate this rail coming from this main track to go to this parallel rail, which is just opposite to this rail, and just again diverging again to that main track to avoid the maintenance work. Okay, so this is the basic purpose of your gunleted track basically. Okay, so you're gonna go through different types of gunleted track. Okay, just try to understand the layout. Okay, this is very important and the main purpose. So regarding gunleted track, we have discussed then what is scissors, crossovers, fine. Then single tip, double tip, diamond crossing. Okay, then your double turnout basically, which is with maybe a similar flexure, maybe having country flexure. Then three switch, three throw switch basically, where double turnout is a modified version of three throw switch. Okay, even three throw switch again have a two type depending on the direction of the movement. Either it may be counter flexure, it may be similar flexure. Similar flexure meaning moving in the same direction, counter flexure moving in the opposite direction with respect to the straight track or main track. Okay, symmetrical split where the radius of the um, your main track and the branch track are similar. Okay, or for your counter flexure or similar flexure, you can also determine the degree and radius of branch or turnout using this formula. Okay, so I'll show you just a basic diagram of a turnout, or you can say railway junction. I think this is already you have seen this railway junction, so that It will make you more clear. Now you can see. So what kind of what type of is this crossing? You could also consider this as a diamond crossing, right? So depending on the purpose, or depending on the space available, or depending on the volume of, or you can say traffic volume. That means what is the number of traffic or railway or rails moving a particular time within a particular time. Depending on that, a railway junction is designed basically. Okay. So here you can see different diagram of this junction. Here you can see it's a larger one. You can see it's a giant level of railway junction. Okay. If you look closely, you will find different types of railway junction here. Okay. So you can see for this, you can see it is similar in going in the similar direction, isn't it? Although it's connect to the different junction, a different track here, but although for this is a main track. Suppose it's a branch track, it's moving in the same direction. Okay. So depending on the direction, also depending on the purpose, also we can classify different railway junction. Okay. So this is all about today class. We have discussed about different types of uh, rail junction. Clear? So with this, I just want to close my sharing. Any doubt till now?
No, sir.
Okay. So roughly we have completed fourth module. We're going to finish the whole chapter, whole syllabus within a very few time. We don't have much classes left. So only left fifth module. That is, it's all about your traffic signals. Okay. So basically, what are the signals? Different types of signals can be used for railway. We're going to study about the basics. Okay. So
Sir,
here I just want to close my recording. After that, I'll just take your attendance. Okay.